Hello, I'm Sterling Barrett from the Acceleration Consortium. I'd like to give a brief overview of the training programs that are going on at the Acceleration Consortium. So, training in general in the space of self-driving laboratories or autonomous experimentation is a lot like playing Mario Kart sometimes. Building one of these labs, you have some configuration of tools and people, and that all kind of plays into the overall functionality that's available there. This kind of begs the question, if you were given the choice to hire somebody, would you hire Mario, Baby Peach, or Bowser? You've got like all around versus great handling versus great speed, and of course ignoring child labor laws and anger management issues. And so it kind of begs the question, how do we deal with this when we have people who are classically trained in one discipline and kind of bolstering the cross-discipline expertise? Take a profile, classically trained physical scientist, maybe some data science experience, maybe not a lot of robotics. And there needs to be someone or something that glues together these cross-disciplinary skill sets. A lot of times it can be like speaking an entirely different language, konnichiwa versus bonjour. And if you take the extreme case, imagine what the dot product of each of these are. Low magnitude, right? And this kind of cross-disciplinary communication requires a shared vocabulary as well as conceptual understanding. So in these two extreme cases, we'll take an aryl halide and a posterior distribution, or a chemist and a maybe probabilistic data scientist. And if you give this definition, an aromatic compound with one or more hydrogen atoms and the aromatic ring replaced by halogen atoms, that may not mean very much to this probabilistic data scientist. So why not show a formula? Still might not be clicking. How about a visualization? Maybe not still. Let's do the flip. So posterior distribution is a conditional probability that updates the prior probability with information from the likelihood via Bayes' rule. Crystal clear to a chemist, right? Well, why don't we give a formula? That should help. And if not, then what about a visualization? And so this kind of gets into this idea of shared vocabulary and concept, understanding of concepts. And so we need to kind of meet where people are. So data scientists would probably still recognize this as a chemical formula. So give it something like that. In terms of visualization, maybe something like this would be a little bit more intuitive. And let's add some labels to connect our definition, our formula, our visualization, and the legend all together to try to encapsulate that. Same thing over here. Let's, have this correlation between, prior, likelihood, posterior in the equation. Make sure we have those defined, as well as some additional context for what we're doing. Okay, so that's just one example. We have created a variety of programs and courses and other things to help people get up to speed with self-driving lab concepts. We have a set of micro courses. It's a set of 5 micro courses. It goes from a hello world, building a kind of small minimal working example, getting deeper dives into data science, robotics, software development topics, and then culminating in a sort of design or capstone project that's in person. First 4 asynchronous, each 150 Canadian for the registration fee, most of which goes to the university. And then we have our design project, which is in person. And the first course uses physical hardware. We really try to emphasize this hands-on experiential learning. So here you can see a microcontroller, a light sensor, and red, green, blue LEDs to do this kind of color matching optimization. We structure the courses in this format of tutorial, quiz, and assignment, with all the assignments auto-graded. And just to walk you through some of the modules there. So first, we get people oriented with an assignment, the tools they'll be using. We have people run this demo with a batteries included version. And then we start walking people through how to build this from scratch. And so dealing with microcontrollers, kind of the basics of sending a command and receiving data, looking at some optimization methods and moving past traditional design of experiments, how to get devices and software to communicate with each other, looking into where we put the data and database management, and then finally bringing these all together in the same system workflow to have our first kind of like hello world to self-driving labs built from scratch. And I think that the community is going to face significant challenge when it comes to an absence of standard choices in tools. As an example, one of my favorite courses, which was programming based and all about machine learning and learning algorithms, we were given the option to use whatever programming language we wanted to. However, the TAs would only be able to help in Python, and all of the course examples would be given in Python. Now, I love Mathematica. It's a great language for symbolic mathematical computing. I decided I would try to use this for the duration of the course. And what I found was I was unable to help most people with most of their assignments. And the converse was true. I was not able to receive help from others very much. So there's a certain break that comes from this standardization mismatch. So let's also talk about conventions. I don't really like the word standardization. It kind of has this top-down, bring the hammer down on what we need to do. I like the idea of conventions. And Tim Peters, really instrumental in Python, said a universal convention supplies all of maintainability, clarity, consistency, and a foundation for good programming habits too. What it doesn't do is insist that you follow it against your will. That's Python. And we're trying to do something similar within the training lab context for the different hardware and software tools that you'll be using in self-driving labs. We have several community-driven resources that can help minimize this redundancy and maximize alignment between different groups. On the left, we have this awesome self-driving labs GitHub repository with quite a few contributors, and so this contains lists of different review papers, manuscripts, different software and hardware tools that people have used in this context or are trying to use. On the right, we have the Accelerated Discovery Discourse Forum, and this one was launched about 8 months ago. So far, it's had around 30,000 page views, 73 different discussions, around 300 users that have signed up and are participating. And for this one, it's a resource that I think can help kind of bridge the gap between, let's say, Europe and North America in terms of the kind of systems we're looking at. In our physical training lab, we have a variety of low-cost and high-cost tools. This we can call a frugal twin concept. So similar to a digital twin, but with cost as that axis. And so we have a variety of types of equipment, from characterization, prototyping, dispensing, sample transfer, different synthesis modules, and really trying to cover the gamut of hardware tools that somebody might use. Within the training lab space in Mississauga at the National Research Council, sort of the National Lab of Canada, we have people who come in to do various research projects in the context of training. Some domain scientist that comes in and they have very little expertise on machine learning, on robotics, automation, and bringing in a kind of self-contained project where they're trying to implement some of these things. So here you see Matthias Gromlich's project. He's a visiting PhD researcher from Germany, and he's setting up some semi-automated electrochemical corrosion cells, and we're using some resin-based printers to have chemically compatible 3D printable electrode cells, which are being helped in terms of the design from Bohan, a local consultant for the Acceleration Consortium. We've run some different hackathons. This is the Bayesian Optimization Hackathon. We had 44 teams, 120 participants, around 60 different organizations across the world, something like 10 different countries that were represented, 60 different cities, and this was co-hosted by one of the AC's partners, Merck KGaA. We have different training workshops that we've conducted over the years, and we also do some outreach, science fairs, expos, lab tours, and things like that. And just at a glance, within the courses, we have 2 launched, 2 that are in the pilot phase, around 108 different registrants, and we're working on a full-length academic course for the coming winter. We've hosted 4 different seminars, 9 workshops, 2 hackathons, 2 high school events, and we've spent around 270,000 Canadian for equipment for the training lab with around 500 unique line items. In total, this has accounted for around 5,000 person hours worth of training received, delivered, and around 700 unique participants. So there we have it, AC training programs at a glance. Thanks.